Bismillahirrahmanirrahim. Today I am going to discuss about the topic comparing means one or two sample t-test. Let's discuss about the t-test concept in general. T-test and z-test are commonly used when making comparisons between the means of two samples or between some standard value and the mean of one sample. There are different varieties of t-test which are used in different conditions depending on the design of the experiment or the nature of the data. In simple words, when we want to know the similarity or the difference between the two groups, either these groups are related or unrelated, so in such scenarios we use the t-test or the z-test. Normally, T and Z test are the same rationale, but these are different. But Z test requires the exact population mean, standard and standard deviation. In real life, the population mean can be known, but what is the exact population standard deviation, it is quite impossible to calculate or to find. Like say for instance, when you are examining the blood samples which have variety of ranges for different tests, so it is possible to know the population mean, but exactly to find out the population standard deviation cannot be possible. So in such scenario where population standard deviation cannot be calculated exactly, we use t-test or we go for the t-test. The other thing about the t-test that the t-test can be used with a small sample size of 30 to 40 and it provides the same results as from the z-test. There are different types of t-test like one sample t-test, independent sample t-test and dependent paired sample t-test. Today we will go only for one sample t-test. One sample t-test is used to compare the mean of a single sample with the population mean. Like say for instance, an economist wants to know if the per capita income of a particular region is same as the national average. A market researcher wants to know if the proposed product will be able to penetrate to a certain level in the household in order to make its introduction profitable. The quality control department wants to know if the mean dimensions of a particular product have shifted significantly away from the original specifications. So in such scenarios, we can use one sample t-test. There are 4 assumptions before you are going to carry out one sample t-test on any data. Number 1 is your data should be continuous, means the data should be in decimals or fractions. The data should be independent. Means there must be any sort of interdependence among the observations or among the values. The third observation is there must be no any significant outlier, abnormality. Means to say, number 4 observation, there must be no abnormality, the data must be normal. After meeting these 4 assumptions, you can go for your one sample t-test. We can generally just after careful observing the data set, we can easily know about the first 2 assumptions, but for the rest 2 assumptions you have to go for the SPSS. Let's study the one sample t-test with having a practical example. Like say for instance, assume that a company produces a product having average weight of 50 kg, and being a production manager, you ask your technical assistant to note down the weight of the 20 units at random out of 500 units in total. And your question in mind at that moment that whether the sample mean is statistically same or different from the population mean. Basically, being a production manager, when you are going to place the order to the client, you make ensure that whether the quality dimensions are as specified by the client are fully meet or not, whether the weight of the the weight of the units or products is the same as we mentioned or claim in our journal marketing campaign, which is in our case it's 550 kilograms. So if there is a bulk of units, so it's quite impossible to know the exact population to weight the each unit separately and go for the one sample t-test. So therefore, to ensuring that whether I am going in the right direction or not, we took on a random basis the 20 sample units from our warehouse and take down the net weight of those 20 units, and I will compare the weight of these 20 units with my population mean, which is 50 kilogram. Like say for instance, your technical assistant provide you the data on a piece of paper in which the number of units given, serial number, and the weight of each unit is also provided over there. So from here we can see that our 2 assumptions are successfully made, that the data is continuous in nature and there is no interdependence of the data among each other. So 2 assumptions are fully achieved. What was our question? Our question was whether the sample mean is statistically same or different from the population mean. Apparently I can see that there are some of the product weights having less than 50 and having more than 50. So but statistically whether this difference, the plus minus, is acceptable or not, means to say for this question, when I want to answer this question, I will make 2 hypotheses, testing hypothesis. First will be the sample mean is equal to population mean and the sample mean is not equal to population mean. While when we are going to carry it out the one sample t-test in SPSS, we will go through the following steps: analyze menu, compare means, one sample t-test, insert variable in the test variable box, provide the test value and press OK. You will get the desired result. Let's do the same scenario in SPSS. I entered the data in SPSS having 20 units and the same weights that provided by my technical assistant. Once again, to check the assumptions, I can see that there is no interdependence among the variables, and similarly the data is continuous. First two observations are fully made. Now I want to know about the other rest of the two observations. For that purpose, I will go for the Analyze menu, Descriptive Statistics, Explore portion. I will enter the PW. PW means product weight, which were taken by my technical assistant, 20 sample units. I will enter the PW in the dependent list. In statistics, I will check the outliers first, press continue, and in plot chart I will uncheck the stem and leaf descriptives, and I will check the normality plots with test. Press continue and press OK. You see, first of all I will see it for the outliers. So I can see that from here dot box there is no any significant outlier exists in my data, because if there is any significant outlier exists in my data, it must be reflect in this box either in the form of star or in the form of circle. So there is no any star or circle exist with having any value, so there is my third assumption is meted, that there is no significant outlier exist in my data. The fourth one is about the normality. So here I can see that Shapiro-Wilk test, in which it is stated that if the significance and p-value is greater than 0.05, it means that your data is normal. So in my case, having 20 observations, the significant value, the p-value is greater than 0.05, which is 0.119. So the data is normal. My four assumptions are meted now, so I can run the one sample t-test on the given data set. So in order to run the one sample t-test, I will go once again in the Analyze menu, Compare Means, one sample t-test. I will enter the product weight. This is my test variable, in the test variable box, along with the test value, which is 50 kilogram. 50. I want to check the average weight of the sample product weights, sample units, with my population mean, which is standard value, which is 50 kilogram. Just press OK. So here you can see the two tables. One is one sample statistics and the second one is one sample test. These are the same tables which will you get as SPSS output. Here you can see that the mean is greater than the population mean, which is 50 kilogram. So I can say that the difference between the sample mean and population mean is positive in nature, which is provided already in the one sample test table, the table number 2, that is 3.70. So there is a positive difference, but I want to know that whether this difference is significant or not. For that purpose, I will check the significant two-test value, which is 0.223 greater than 0.05. So therefore I can say that there is not a significant difference between the average weight of sample units in contrast to the average weight of the population of 500 units. As a food for thought, I am providing you how to report the one sample t-test value. Based on these two tables, I interpreted my results in this way, that based on the 20 samples data collected from the production unit at random, having a sample mean of 53 kg, which was tested with the population mean of 50 kg. We found that statistically there is insignificant difference. T19. What is 19? 19 is basically degree of freedom which is provided in one sample t test df equal to 1.259, which is the t value, comma p means significance value, which is 0.223, between the average weight of sample products in contrast to standard weight of the product, that is 50 kilogram. I hope you guys understand it. If you have any question, please write straight away to me. I will answer you inshallah. Thank you very much.